Hey guys, welcome back to CMTEQ channel. So a while back I did a tutorial discussing the dimming capability of this LED driver. We even demonstrated how we could dim these DC track light, okay, via the dim plus and dim negative using the external power supply. In this tutorial, we basically bringing in the IoT integration into the system. So if you haven't watched that tutorial, I really recommend that you watch it because we are basically building from that. So in this tutorial, we're going to demonstrate what we did in that tutorial, but by bringing in IoT integration. So basically, instead of dimming directly by applying an external power supply into the dim plus and dim negative, we're going to bring in the power supply into the ESP device here, okay? And the ESP device is just not going to dim the light by itself. It's going to be receiving commands. So the commands are going to come from the cell phone application here that is creating basically MQTT topics so that you can send commands. Then obviously these commands, they need something that must handle it. So that is the MQTT broker. So we've got a server here that basically running. I also have a tutorial whereby I discuss how you can set up an ESP as an MQTT server, right? So once a server handle our commands, this ESP subscribe to the commands, he receives it and he send it over here, obviously. Then based on the commands, the ESP is going to execute the control, either to turn on, off, or to control the PWM. And that's going to be fed here on this simple RC op amp circuit here to basically create a 0 to 10 volt dimmer, and that is indeed being fed here into our dim plus and dim minus, and as a result the track light here will be controlled, okay? And to ensure that we are actually controlling the LED brightness, because we will be monitoring the input power, so we've got an energy meter here that we basically probing via the RS485 Modbus, and to ensure that we are able to track the power and see that we are able to dim it using this cell phone application, okay, we have a PC application that basically going to confirm for us here. So we've got the voltage, current, and power. That will be the real-time voltage, power, and current coming from the energy meter here, which is connected on the input of the LED driver. So basically the LED driver here is receiving power from mains through the energy meter, which has an RS485 Modbus system that we are using to basically sniff and displaying the result here. And over here on this side, we're basically going to display our MQTT commands and status as we are busy executing the control. So if you find this tutorial useful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Great stuff. Now, before we demonstrate, cross our fingers and demonstrate, let's quickly do a walkthrough of the code here. So the first code obviously is the ESP server code. So that is the code running here in this ESP module, because the commands are going to be coming from the cell phone application, which is based on an MQTT Explorer app. Okay, so over here, I've already configured and set up the app to connect to the server. Now, I've done tutorial about this already. Please check the link in the description box. Now, once I send a command, obviously the MQTT broker is going to manage that, which is basically just here we've created a simple MQTT broker using the micro MQTT broker library. Very simple, okay? And once the command is sent, okay, this ESP here is also, just as the cell phone application is registered to this MQTT server, the ESP must also register and connect to the same MQTT server broker so that it can see the topics, right, as they comes in. So the topics of interest are these topics here that I have set up here. I'm going to show you one of the topic that I've set up here is ESP8266 command, right? So this is a very important topic for this ESP. So he must check the message coming from these topics. Once he sees a message that is linked to the code running over here, okay, then he's going to start executing either on off or executing the PWM control. So the code running over here is very simple. We're basically just doing an analog write based on the instruction that will be coming from the MQTT topic, which is this particular topic. Now, I've also done a tutorial already about this. Please check on my channel. The difference here is that we are bringing everything together so that we can control and execute dimming of an LED via dim plus and dim negative. Now, the last part of the control is the 0 to 10 volt controller that we've got here. Because as we know that the ESP8266 can only output a PWM signal with amplitude that can go only up to 3.3 volt based on its design. Okay, so what we then do is we feed that 3.2 volt into the RC filter here, okay, and then we buffer it into a non-inverting to create a 0 to 10 volt. I've done also plenty of tutorial about this particular circuit with an Arduino. Please check the link in the description box. Okay, then at any given time, let's say our duty cycle is 50%, we're going to have about 2 volt or 1.5 volt depending, and that is then going to be scaled up and then feed here into the dim plus and dim negative. So that's basically how this circuit is going to operate. And from there, the LED driver is going to do its magic to then control the dimming. Because without that dim plus and dim minus over here, it's very difficult to actually execute LED dimming if that provision is not in place, because the constant driver or constant voltage driver here is already designed for specific conditions. So once you start playing with the current and voltage control, it's going to sit as a fault and it's going to shut down. Your LED will basically switch off, so you won't be able to execute control. So in order to execute control, your LED driver must have dimming capability, which this particular one has. It is time to start testing. Okay, so first I'm going to go ahead and switch on my power supply here. As you can see, the ESP here is ready, and we can go ahead and measure. Let's see if I can bring the multimeter on the screen here. Okay, so there we go, and we're going to measure over here. We're currently getting 0. Okay, we're currently getting 0. The ESP is alive. Okay, it's working. The reason being because the PWM control is not working yet. So let's bring the dashboard here. Okay, so now we need to ensure that the cell phone application is connected. Okay, as you can see. So to be certain of everything is running perfectly, I just need to reset the server here. As you can see, when I reset the server, then I'm going to reset my connection again also here. You can see right now it's not connected. Just need to reset. It is connected, is now happy. So now I need to go ahead and switch on the light. Okay, now I've injected power into the track light. As you can see, you guys will be able to see that it is on, but it's not full bright on. So let's start monitoring. Now, as you can see, we've got 234 and we've got about 0.044 amp. The power is very low because it is at its lowest. Now let's go ahead and just measure here. Okay, it's 0. So now I need to start controlling. There we go. Something happened. You see the power jumped to 8.5. The power jumped to 8.5. Let's measure the PWM RC. You can see the RC output is 0.5 volt, okay? And if I measure on the output of the op amp here, you can see it's 1.7. And you can see here, the PWM is at 43, okay? So I'm going to go ahead and just increase to 94. And you can see my power here is also increasing. And how much power we've got here, 15 watt, okay? And if we measure over here, it's now at 1.2 volt, and the output here is at 3.8. Now let's go all the way at 232, almost 255, and the light is full bright on, as you guys can see, and the power is 33 watt, okay? And if I measure over here, it's 2.7, and over here it's now at 8.6 volt. And if we put it full power, okay, so that will be about 36 watt, 35, okay? And the PWM, the maximum here, we are at 9.1, okay? And here we are now sitting at 2.8, 2.85. And for some reason, at 100%, you can see 255. I'm not getting a full 3.2 volt. Please drop a comment in the comment section. Let me know why is that the reason. How can I make sure that I get the full 3.2 volt that is supposed to be available on the output of my op amp? You can see here, this is D1, the pin that I'm actually controlling. The PWM is sitting at 3.2 volt. Okay, here at the input, it's also 3.2, but the RC filter here, the output is only 2.8. So for some reason, I'm dropping some voltage across this 10K resistor. So I probably need to increase that value so that I can minimize the drop there. Otherwise, the correction must be done over here on the output, where I can scale up here so that I can amplify it more. But for the purpose of PWM dimming LED control via an IoT application, so I can walk around with this cell phone, assuming that I remain connected to this broker here, I can still do the control, right? I can still do the control. So let's see, now I'm decreasing. Let me go all the way to 0. Okay, so at 0, PWM control here, I'm now sitting at 0 watt. Okay, now it's 4.5 watt for some reason. Okay, so that is a discrepancy I probably need to work on and resolve. You can see the output of my PWM is 0.2 on the RC side, but on the side of the ESP, it's 0.196. So that is an issue I need to look into. Why is it not 0? Please let me know in the comment section, okay? Because that is the reason why there is a little bit of light here. Okay, it's supposed to be off. As you can see, it's cycling between 0 and 4.4 watts. So it's very little power to be measured. So obviously, the energy meter here is trying to measure that little power. So that is it, guys, for these very simple IoT integrations of an LED dimming application. So the end goal here, if you're going to stay tuned onto CMTEQ channel, is that I want to design a very small PCB that will take the RC filter here with an ESP together with a small power supply and build it into the track light here and be able to install it somewhere. That way, the ESP will connect to my broker here and I can control using my cell phone the light level wherever the track light will be installed. So if you found this tutorial useful, please make sure you subscribe and stay tuned for more upcoming tutorial in this topic of IoT integration ESP8266 devices. Until next time, cheers.